Então, a seguir, nós ouviremos uma conferência sobre planejamento e projetos do Porto de Liège, na Bélgica, que será proferida pelo engenheiro David Monfort, da Universidade de Liège, na Bélgica. O mediador será o professor Dr. Paulo Pellegrino, da Faculdade de Arquitetura e Urbanismo da UF. Senhor David, por gentileza.
Já chamou.
Segunda você perde a base do filme. Então vai aqui. Vai lá. Vai.
Bom, boa tarde. Então, acho que, como foi anunciado, podemos dar início então à conferência do David Monfort. Please.
So, thank you, everybody, and good afternoon. So, first of all, I would like to thank all of you for your presence, and I would like to thank the organizers, especially Wagner. Wagner called me a few months ago and invited me to the seminar. So, thank you, Wagner. It was very kind of you. I would also would like to thank Roberto for his support and his warm welcome. And I have a special word for Saidi because I know she spent a lot of time and a lot of energy these last months to prepare this, and it's kind of a great achievement for her. So congratulations, Saidi. Right now, I would like to make a short introduction, because yesterday we talked about black sheep, and unfortunately I'm one of them. I'm a civil engineer, and when Wagner asked me to talk about urban ports and relationships between hydraulic structures and town planning, as an engineer, I thought that the best way to explain our work and the concerns I wanted to develop today was to start with explaining you how we work inside our study office and the close relation that we have with architects and town planners. So I will first show you a few slides of our study office and our past realizations as an example of what we do, and then I will come directly to the topics of the day, that means the hydraulic works. And also, as an introduction, I would like to say that technical aspects and architectural and town planning aspects are very close to each other, are very linked, and it's always the starting point that might be different, but at the end, everybody has to come to the same point and to gather. And it's really the red line of my speech today. It's talking about technique, but not as a purpose in itself. Technique only helps to achieve other aims that are connected to people and water and well-being along the water. So we come from Belgium, so I think we've already spoken a bit about this country in last days. We have two offices, one in Brussels and one in Liège. This is our team, so about 108 persons, engineers, architects, and technicians. This is important to mention that we have a small group of architects inside our team, and this is due to the fact that our founder, Liège, had both diplomas, as well engineer, as well as architects. And we always try to give this idea in all our projects, that we have to work together, to collaborate, from the very beginning of the studies. And this is the reason why we have an internal architectural department that helps all the engineers, all the departments to give this sensitivity inside the project. I will go quite quickly through a series of projects that we made during the last decades, such as bowstrings here over Albert Canal. Another one, which is a bit different, but we always strive for simplicity and for logical integration. This one was a cable stay bridge, which was built on the side of the river, and then was turned in its final position. And I show you this example because it's one of well, how can I say it? One of the specificity of our studies is that we always try to find clever ways to build the structures in a safer way, quicker, and also to improve the quality of the final elements, such as concrete parts. This is another realization in Tournai along the Ciel. And for this realization, we've worked with French designer Nicolas Michelin, because this is another fact that as a study office, mainly composed by engineers, we are, I would say, daily working with town planners, urban landscapers, architects from other offices. So this is really rich, and it's important for the project to mix all competencies, all knowledge from town planners and engineers. This is another example that has nothing to do with waterways, but I wanted to show you because it was quite funny. That China was built completely underground, and it was then rotated in its vertical position. It also had a lot of advantages for safety reasons and for the rapidity of the construction. This is another bridge which I'm really proud of. It's called Eau Rouge, and it crosses a valley which is a very sensitive environmental area. And so we had to do this huge arch with the simplest structure possible. Those are high-speed trains, high-speed train bridges. This one studied with French architect, and this one was designed by Santiago Calatrava in Orléans, and we made stability studies for this complicated bridge. There's another example. This one is ours, so sometimes we do the architecture ourselves, and this is the case for this bridge in Monfort. This one was the last bridge of René Grèche. A few months before his death, it was inaugurated. It's a full bridge in Maastricht, in the Netherlands, with a single arch, and it connects a new housing area and the park on the opposite side of the museum. It's very much appreciated by the citizens and the bikers. This is another example of what we can study. Again, with architect Santiago Calatrava. This is the railway station in Liège, where we had to do all the stability studies of this complicated structure, but really fantastic station to, I live in Liège, and this is really something that enhances the quality of a whole city. This is another example of structures that we are to study. This is a tower that's in Qatar. This one was also a great achievement. It's a new viaduct in the south of France, designed by architect Norman Foster from England, for which we did all the stability studies. As other field of activity, we are also specialized in airport infrastructures. And And this is another example of bridge that we designed ourselves. It's at La Réunion, so in the Indian Ocean, where there are lots of huge valleys, as this one, where lava runs through the ocean. So it gives the occasion to design quite interesting bridges. This is another structure that we had the opportunity to study. It was designed by architect Prof, and we had the responsibility of the stability of all the shells. Those are structures combining wood. All the shells are different, and the result is really spectacular. This one is the last bridge we studied in an international consortium, and it's in Istanbul. It's the third course of the Bosphorus, so it's a bridge of more than 1.4 kilometer span, and it combines two techniques: the technique of cable stay bridge and the technique of suspension bridge, which is quite new. This is the financial tower in Liège. We just finished with architect Jaspex from Russia. And this will connect us to the waterways, because this new lot in Alpin just been, the study has just been finished. The project is in tender phase and will start probably next summer. It's a project. It's a very multicultural, multi-disciplinary project. Sorry, with two lots, with a footpath, new buildings, some landscaping with a path for the fish passage to help the fish to cross the 5-meter difference of levels between the two water levels, and it also includes some railroads. So this is kind of the kind of project that we appreciate, because they mix up a lot of different aspects. And to end up, I'll show you just a picture of our office during meeting. So it's open so that everybody can work and talk with everybody. And it's in the forest, so that we keep in a quiet atmosphere to think and to be as efficient as possible. So I go on with the topics of the day. This is the program, the schedule of my presentation. I'll start with a general introduction, 2 examples that were not studied by our office, but that for me are quite representative of what I want to tell you today, and I'll end up with 3 quick cases, 3 structures that we studied ourselves. So first of all, I start with a picture of the Port of Antwerp. We've already spoken a lot of this huge port yesterday, about more than 8 billion containers a year. It happens in all the marine harbors throughout the world. They are getting bigger and bigger, and they accept large boats every day. That means that those boats are discharged very quickly, and there is a need for those boats to get rid of those containers as soon as possible, because of a lack of a place to stop all of this. There is also a steadily growing ask for quick delivery, so everybody wants to get rid of those containers as soon as possible. That means that you have to build huge locks. This one is the Kielrecht lock in Antwerp, known as, maybe Gilip will correct me, but known as the largest lock over the world. Again, these locks help the large boats I've just shown you to get inside the port. So slightly, you see where I want to go to. Those limits are always pushed a little bit further. That means that if you come with a greater boat inside the harbor over the first locks, as soon as you're over there, technically you're in the inland navigation. And accepting such goals in inland navigation requires that all the infrastructure that is behind this point needs to be improved and needs to be enlarged. This is an example of ships that are navigating through Canal Albert, so coming from Anvers and going upstream. These are two other examples of boats arriving in Liège, in this case, with containers or with a cold stuff. And as you can see, those boats are, of course, also getting bigger and bigger. So we have two questions with this, and I've written them down here just to help us think about. What is the future of the former urban ports? Because it has become an evidence throughout at least Europe, for what I know, that the old city ports that were located downtown and that mainly were responsible for the growth of the city. They were part of the beginning of the city. Well, those ports are certainly too short, too narrow to be able to deal with such huge boats and such number of boats. And the second question is how to integrate the new harbor zones inside rural sites. Because, of course, every city has decided to build their new harbor areas outside the cities, just outside the limits of the cities. So you have two questions inside one problem. I don't pretend to give a general answer to this, of course, but this will be the few examples that I will show you just now. I wanted to show you those kind of pictures because it's I will say it's another question that I wanted to mention though. When you go up in the hinterlands, you are subject to cross those kind of landscapes. So the question is also to protect these landscapes. Besides the fact of building a harbor or not, the boats are crossing those landscapes. There are some banks that are very fragile. There are all ecosystems that have to be protected, even against the defective navigation. Those kinds of cliffs are also met along channels. So to deal with these questions, I will have a first example, which is one of the Port of Brussels. Here you see a general map of Brussels, and this red line figures what is now called the perimeter of the Grand Canal. So you must know that through Brussels runs a small river which is called the Seine, not the Seine like in Paris. It's nearly the same, but it's Seine, and it used to be a very little river that has been transformed into a channel. So the boats can ship through the center of Brussels through the channel. And it has been one of the elements, one of the major factor of the economic development of the town, mainly for cement fabrication. So this channel, all the portuary zones that are located next to it were very important for the growth of the city. And I was talking to you about the Plan Canal because Brussels is subject to the same prospects I was just talking about. The boats are too big, they don't come inside the city anymore, and besides that there is a certain reducing of how can I say, heavy industry inside the city. So the surface that is here in this red line is about 700 acres that the city wants to reorganize following three main goals. Keep the economic activity inside the city. There is still a certain activity with the distribution of cars, for example, throughout Europe. They want to hold it. They have to create housings as an answer to the demographical boom. So they expect about 7% over the next 10 years, which makes a lot of people to host and improve the public spaces. This is of course something that we have already talked about. Everywhere there is a there is a river inside the city, people want to be there. That's the place they want to be. And as I told you, I live in Liège, and it's also the case. Every time there is a little strip of surface that is free along the river, all the citizens directly go there. So it's an answer to the lack of private gardens, of public spaces. So these spaces are very important for the urban development. So they wanted to achieve this third goal as well. What can I say? You've got different kind of atmospheres along the canal in Brussels. Here you are in an industrial area, which is linked to cement, as I told you earlier, and you can see that the surroundings are mainly devoted to industrial activities. This is another another point in the city, still the channel, and you see that it's very more a housing zone. There are innovative neighborhoods. So the answer that the Plan Canal wants to give is different from one point to another. I will just show you one example. It's the old Quai des Matériaux, so-called materials quay, which is now subject to a transformation. This is a simulation of a project of MSA, which is a Brussels architect company, and this will be realized over the next year. So this is an example of the reappropriation of public spaces along the channel. I will talk about the example of Copenhagen, which is very interesting as well. So Copenhagen, this is a general map. The city of Copenhagen is located in here. Those are all channels that are now not used anymore. This is the main channel that used to drain all the navigation through the city. And this is the whole harbor zone. So here with the arrow you see those old docks. Of course, with the same reasons I told before, they had to move with their port, and they did it outside the city, as it looked logical that all marine boats could easier moor over there. And the question was, of course, what are we going to do with those old locks? And they had very interesting answers. So this is the kind of landscape you can have in the new harbor, which suits very few with downtown surroundings. So what have they done? Such kind of things. I think there's a problem with the picture. Sorry, I don't think it's okay. Right. They have modified their old docks. All the buildings that you see there are old warehouses where you can still find the old hooks and the old structures to hang the goods that were discharged from the boats mooring along these walls. And they have changed it, in this case, into housings. In this case, this was the oldest dock at Copenhagen. It's a postal card view nearly. It's called Nyhavn. It was called so New York at this time, but it's not anymore that new. But it's now devoted for tourism and tourism boats. This is another dock that was transformed into housings and bathing area. We are closely connected to the sea, as you saw on the map, and people are diving into the well, it's not the sea, it's the channel, but it's closely connected to. And you see all those wooden equipments to really give the dock back to the citizens. This is something really important. This is another example of an old dock. This one has been earth-filled. You see the old buildings in here. These are offices buildings. They also have integrated museums and public buildings all around those docks with those public spaces that have been completely renewed, that are very welcoming. An aerial view gives you another example of what they've done with their channel, which was finally too wide, because it's funny to say, but starting from something too small, you finally come to something too wide. So they gained some touristical surface upon the river, thanks to Belgian architect Julia de Smit, to offer those kind of structures. And it has combined to all the other zones that I showed you just before. It has really given a second life to the river and to all its inhabitants. Going along the river by bike on both banks is really something fascinating to do. So, having these examples in mind, I will now come to a more technical part of my exposé with 3 different cases. First of all, the Port of Liège. Second, Laney Lock Complex. And third, Saar Canal Bridge. I've chosen those 3 examples because it's a kind of trilogy of what you need to improve an internal waterway due to the increase of the traffic. First, you need ports, you need locks, and you need improved waterways. So that's a bit of a mix of what we have implemented in this prospect. So first, about the city itself, I just wanted to tell you that Liège has always been a steel industry town where there was a lot of coal. I mean, in the past century, there was a lot of coal around the city. So there's always been a tradition of steel making in Liège, as you can see on these other pictures. Well, most of these industries are now closed because it's the rule in Europe. You don't get the chance to make your own steel anymore. It's not competitive. But it's one of the reasons of the growth of the Port of Liège, the fact that we had steel to sell. So, you've already seen similar pictures, but I just wanted to remind you that Liège is located at a very interesting position in the European market. So 60% of the European purchasing power is located within a radius of 500 kilometers, which is not much, and 56 million consumers within a radius of 250 kilometers. So it's very important for a city like Liège, which is not located along the coast, to have close connections to different transport networks. So the water, the rail, the road must be efficient to reach those different markets. Another aspect that is more linked to waterways is the connection with Antwerp and Rotterdam. It takes only 14 hours to reach Antwerp, 12 hours more to go to Rotterdam. You've seen the huge amount of goods that have to be transferred from these ports. It's very important to have close connections with these huge infrastructures. Other connections, as I told you, are also achieved thanks to other ways. So Antwerp is only 130 kilometers by road, Brussels 100 kilometers by road or rail, Cologne 120, also road or rail, Paris 360, Maastricht 30 kilometers by waterway, and Athens in Deutschland 60 kilometers. About the capacities of the Port of Liège at this time, in 2015, the waterway traffic was almost 15,000 tons, 15 million tons, sorry, and water railroad the total traffic was 20 million tons. and we had about 40,000 containers. The important number is this one, plus 27%. So this is something in a very fast increase, and this is the reason why we needed to extend the port. Actually, there are 3 multimodal platforms in Liège. Liège Container Terminal, which is here on the picture, Europort's inland terminal, and DPO, so the new physical, which I will talk about. As another example, this is just a Google view, but about what I told you, this is Liège downtown, and these are the 3 points I've just talked about. This is Rennes, this is Europort, and this is illogical. So we don't escape the same rule as all the other cities. We have to push our harbors outside. What does the new platform offer? Free access to the sea, Antwerp, Rotterdam, and Bruges. 3 transit modes, water, railroad, and 3 cross-border markets. And it might, at long term, multiply by 5 the number of containers that we have each year. This is the main organization of the platform. I start with a bit of logistics, and I'll come back just afterwards to the concept of the platform itself. So here is the canal, here is the container terminal, and here are all the portuary zones with the logistics support. Here is the green belt that has been achieved to protect the village that is situated next to it. I have just a small funny story to tell you. The first hall has been built. It's been owned by Walter de Pau, but the exploitation has been conceded to a French group, which is Tempo One, which distributes all the products of the Brazilian firm Aspargatas in Europe. That includes the Havaianas. So maybe Liège is a bit connected to Sao Paulo thanks to this. Another aspect which is very important is that you don't build such infrastructure on your own. It's important to be connected in an industrial network. This is the case thanks to the relation with the Port of Antwerp and the SPI, which is a local activating partner. And now the first containers have arrived on the platform, so the new container, its new terminal is launched. So I come back a bit backwards. Before building this, what was the problem? Not the problem. What was the question? We are located. This is the view of the Meuse, just next to the future platform. You see, this is a quiet area. We have the side of the valley on the right hand. We have a village on the left hand. And this is the kind of environment surroundings that you have to deal when starting the study of such a huge platform. This is an aerial view. Here is the canal where all the navigation is located. And here is the Meuse, which I show you just at the moment. You see that there are villages at the north part as well as the southern part. So the new platform has to be located here in an interesting place if you see it from the economical point of view, but also a difficult place because of the rural zone. That was one of my questions at the beginning. So a few data. The total surface is 120 acres, and it includes 25 acres for environmental improvement and 15 for access infrastructure. So that means that one third of the whole project is devoted to non-directly protected surfaces. This is important. This is one of the, well, I won't say this is a rule because it would be a bit, it would be a nasty view. It's also a purpose. we don't want to implement such huge concrete surface without spending time and also surface for environmental aspects. But we must admit that it has also become a kind of necessity, certainly in zones that are quite densely inhabited. So in the project, we have constructed here a road network, including a bridge over the highway and the roads, and a series of water zones that are devoted to environmental developments as well as cycling tracks. This is a future view of the complex when it's finished with its series of roads, the full terminal, and some gas surfaces. What is important to see is this green belt, which is half made out of water plants and half made of forest and footpath. This is another view of the completed area. So over a few years, when all the structures will be built. Here are a few pictures of the situation today. This is the first hall that has been built. This is the first third of the terminal that is also already in function. And this is the green zone that is starting to grow because trees need a bit of time. This is the new bridge that we have designed to cross the river and to give a direct access to the zone, because this was also one of the aim, not to disturb the life in the local villages. So this bridge was really dedicated to give a direct access from the highway to the industrial area. This is another view of this new structure. We want it as light as possible, and that is connected to a green axe that I will just show you. This one. We worked with our landscapers to. This is an old dock, an old existing dock, and we continued this line up to the river Meuse, which is 7 meters lower, with a sort of stairs, a series of water plants devoted to working zones, fishermen, and of course natural development. And this axe was kept for the access road, as you can see on this picture. So we were talking this morning about a peaceful approach. That's what we always try to do in this kind of project. Things must look simple, because that's the way they will be accepted, and that's the way people will think that things have always existed like this. So it's no surprise, it's just the way you wanted it to be. It's kind of peaceful approach. I go on with Liège because now that we made a series of poetry zones outside of the city, what happens downtown? This is an old picture from the beginning of the last century, and another one about the same period, so 100 years ago. At Liège downtown, there always used to be a harbor. This is a commercial boat with transporting goods. This is another one shipping through a lock. So there is a waterway tradition downtown itself. But things have changed, and of course, when boats are not supposed to stop anymore inside of the city, you have this waterway that becomes too large, and when you are looking for some place to develop, to build new houses, you start filling these extra wideness with earth, and when it's filled up, you start building highways. this is the way it happened at too many places in Belgium for sure, and probably in other countries as well. So this is an example of what happened during the years 60, so 50 years ago. We built those highways just along the river, which was such an interesting place. And you can believe me, if you are just walking and you want to reach the bank of the river, you risk your life. So the purpose was to change it, to stop those urban highways which have no sense. So we made this, which was achieved thanks to the collaboration of French town planner Michel Courage. So this was a complete renewal of these old areas. Areas in used ports, that's important to say. It was a portuary zone that has been earthfilled and now is given again to the citizens. So we have kept a boulevard which has nothing to do with the highways. We've got crossroads, we've got red lights, a series of pedestrian ways, and moreover, we have given the case back to the people. We have also built this new footbridge that connects this zone, and you'll see on the next picture, this is connected to the station, and this is a park. So there was a real need to connect those zones, and it was really asked by the citizens as well. This is another view of the project that has been achieved last year. So this is the exit of the tunnel. We kept a small tunnel that goes this way, and that helps the cars to get out of the city when they are in this direction. And the rest is really become peaceful again, and is welcoming for all the different type of users. And this footbridge is a connection with the right. With another view that Paula showed you earlier. This is the new footbridge that has been designed for all kinds of users. So people with bikes, people that have mobility problems, and most of all, it's also a place where you can rest. You're not obliged to walk to it. You can lean on, you can sit on the main entrance. This is another view from the right side of the river. This one inside the park. So the connection of a footbridge with its abutments is something really important, because the footbridge will be used if the people can reach it. So we made different ways of reaching the footbridge from different places in the park, or on the right side, on the left side, sorry, of the river. This is another example. I think it's a school, it's a class of a school going to an event and biking through the footway. Besides this footbridge, I told you there is this new area along the Meuse, which has been directly, how can I say, has become a real friend for all the citizens. Now I will talk about another project, which is the Laney Log Complex, and this is a more technical work, but you see that the achievement keeps the same. That means this is an industrial infrastructure dedicated to high tonnage boats, up to 9,000 tons a boat. So it is huge. It is really big, and the goal of the design is to make it human. So to let it keep human geometry, a human aspect. So this was the goal. This is a simulation before the works. We had two old locks from the years 1930, this third lock from the years 1960, and the new lock to be built here. Just a few facts about the owner, which is public administration, Sofico, and Voirie de Liège. Main contractor was SpaceX, and the cost is about 140 million euros, thanks to the support of the European community. So just another few dimensions. The lock is 225 meter long, 25 meter wide. The head is 14 meter. It is managed by butterfly valves and longitudinal culverts. This is the location. You see the border between Belgium and the Netherlands. You see these three old locks, and the new one had to be built upon the border, which led to a series of discussion about financing and compensation zones. You also see on these pictures that we are located in a very green area. It's a protected zone for fish and for a lot of kind of birds. This hill is also very symbolic with a very particular ecosystem that had to be protected. So our first idea was to have a simple geometry. As I told you, there are 4 structures that have been built at different periods, so with different methods and different answers. We wanted to reunify the whole site to make it as simple as possible. That's the way we started to think of making a block, which would involve old material areas. This is a zone that is used for technical purposes. The third lock, the central pier, which I will tell you later, is equipped with a hydroelectric and pumping station. The new lock, and here is also a tunnel, because cars have to reach the downwards zone if necessary. So we had a full structure that we wanted to group so that we could have a simple answer. So this is all, again, a simulation of this block, and the new bridge crossing the whole site has been detached a bit at the downstream zone so that it could simplify the lecture of this lock system. So the lock itself, I won't be too long about the technical aspects, but you must know that there is a lot of technique of, let me say, science inside the structure, such as this is a transversal, a cross-section of the structure with the central zone where the boats come up and down, and the lateral culverts that help to fill and empty the lock. And this structure lays upon different layers of ground that are particularly sensitive to underground water flows. So we had to build those diaphragm walls all around the structure to ensure that we have a long-term stability of the structure. This is kind of things that you don't see, of course, when you come and visit now. Another aspect I wanted to talk about is, for example, the upstream door. You see these old structures that had been built previously for the 3 first locks. This is the new structure. I was talking about simplicity. This was our goal in this case. This is a photo of the door that lies under the water, just of course during construction stages, so before filling the lock. And this is just an example of the calculations that we made for the design of this structure. All the equipment that is needed to steer the door is located into a very minimalist block, and everything is, nearly everything is inside the ground, so that you have something that keeps at human size. I have a small animation. I hope it will work. Doesn't seem. Just wait a minute. Let's it should work. It's a video. It's a video that should go.
Do you have a separate file?
No, it's inside. Well, okay, sorry for this. I will try to explain you without the video, but what you must know is that this structure is just put inside a small concrete structure which has a steel grid so that it deserves natural light. And these jacks activate a kind of small car, let's say, which is on its rail, and which itself activates these bars that are connected to the door, so that everything moves under the concrete surface. I'm sorry for the video. This is another view of the downstream door, and what is interesting with this is the huge size. You see here this elevator with the guy working on this. This is about 20 meters high. So those are huge structures, partly under water level, but they have to be built as simple as possible to be again in the same simplicity aim. I told you about this structure. This is located in the center here, and it's also in the context of a sustainable world. As soon as you build such big blocks, you have a great water consumption, and by dry periods, you might have some problems in the river because of the consumption. So we have built in the middle of the central pumping station in this situation, so the water comes back to balance the weekly consumption of the whole site, so we need 4 blocks working together. And in wet periods, then we have on the contrary, on the other hand, we have too much water, so we need the same infrastructure to produce electricity. That is, of course, an interesting sustainability of the project. I told you about the bridge. Here again, we wanted to have something simple and sharp. We have a steel box girder and a concrete deck over it. Just a single pile at the angle, and this 90 degrees turn keeps very light. Another related work like the design of the new control building, which will take the lead on all of the blocks. And of course, the development of environmental zones. This is a fishing zone, the reproduction of the fish, which has been built out and which has been planted so that with different width of water, you can welcome a large series of other related works, such as hydraulic studies in that collaboration of the University of Liège, were also important in this project, in this multidisciplinary. I have now a series of pictures of the construction stage. You will see all the technology. The kind of war during the beginning of the works, with the concrete plans, the inside of the gravel that underneath the ground, they have those huge cranes and a lot of sheet iron works as well. The faster, the fastening the bridge. This is a huge sheet fire. Those with the completing of the downstream with the construction of the bridge, and here you can see the 4th block being started. The 4th block being reinforced and completed. This is a view of the empty block, which you can see the 2 guys making a screen inspection. This is something very impressive. about 22 high. And we often say that sometimes when you have to build a very, very big structure, such as a retaining wall, before building it, be sure that you really need, in this case, because you want to develop the navigation. But when you see those huge structures, and you translate them in another environment, such as retaining wall, I know that there are many cases where, if you think about the topography, about the geometry of the work, sometimes you might even not do this work with this wall. So, it's something that we must keep in mind, and it's closely connected to what we said this morning. Is that you don't have only to think about how to solve the problem. You must also think about the question why. This is the final view of the lock that is now in service that is used. You see the lock, the door I was talking about, which is really good. You see all these zones that have been replanted. There are some parts, of course, nature must take a time to grow and to develop, but mainly required to give the complex a unity and a kind of peaceful context that it deserves, that it certainly deserves. And last of all, I will talk a little bit about SAF language. So what was the purpose? This is just a view of the existing zone. You have a highway in here. This is a speedway crossing the highway and going to the south. Here is an industrial zone that already existed and that was subject to development. And this is a village, the village of NUTAU. And you can see here on the right side the extremity of the existing canal just before the construction of the bridge. And the purpose was to build a bridge for the canal in this direction. And this led to this construction. It's important to say that this is a valley, not a very big valley, but a valley nevertheless that is where is a small river that is partly on the ground and partly on the surface. Of course, this bridge is 500 meters long. The dimension just have to move. There's no way of earthing the whole valley, of course, because of the river, because of the village, because of the road, and because of all the surroundings, all the views that we want to keep. So it was decided to build a canal bridge that you see here in the lateral view of about 500 meters long, of 33 meters wide and a useful width, with a series of piles with a distance of 38 meters. So that means that you have a series of square shapes, or nearly square shapes. And if you know a bit about concrete design, calculating such huge plates of about 35 meters along each side is not something that easy, because the width is similar to the span. So we made a series of simulations for the works to show how this new bridge should be integrated into its environment. And you see just as an introduction the picture of the work that has been done, and it looks quite like the simulation you showed. What are the specificities of the structures we designed? The side walls are viewed as main structural girders. So that means that we don't have any longitudinal beams underneath the structure. It's the structure itself, the lateral walls that are used as beams. We give the structure a high hyperspecificity degree, which will give nearly no joint, one limitation joint, one at each extremity, but no intermediate joint, so improve the waterproofness. A limited number of supports, I told you only 38 in each tier, and a series of transversal beams, a crisscross transversal beam. So this is the cross section. All the structure is fully in concrete. You have those transverse beams, precast and crisscross transverse beams, and all the rest of the structure was cast on site. You see the lateral view. We imposed casting with wooden elements, small wooden strips, so that it would break the linearity of the structure and give it a rhythm. This rhythm is reinforced by those elements that are located in front of each pier and that reinforce the structure to have a place in the supports. Why are you chosen for a trapezoidal shape? It has better hydraulic parameters than a rectangular shape. You need to understand because we have extra wideness where the boats don't ship, and that can help water to flow around the boat easier. So it widens a little bit the hydraulic surface. It gives a protection of the bearing elements. So this concrete plate helps protecting the bearing elements from the boat shock, and it provides a footway on the other. So this is the cross section that has been designed. Something important is that there is a lot of pre-stressing in those structures. Concrete is watertight if it's compressed. Whether you start having some traction, it's bad for waterproofness, it's bad for durability. So in this structure, we wanted that all the surface of the concrete that would be in contact with the water should be kept into compression. So there was transversal pre-stressing. This pre-stressing was organized in a sort of V-shape, as you can see on the upper view. There was also a longitudinal pre-stressing. You have two kinds of pre-stressing: a straight one, which was used during launching, and a wavy one that was used in service. The wavy one goes this way. Just a picture to show you the complexity of the reinforcement and all the tubes that are placed to host the stress. This is another view of the casting of the structure, or with modular elements. We did some other actions to ensure the waterproofness of the concrete. We gave it an inner capacity by choosing the ratio between the different components of the concrete. We placed this post-stressing I just talked about. We limited the number of joints. We added a waterproof adhesive sheet, and we imposed a special upper cast material to avoid air bubbles. So those were all the impositions that were given to the contractor before he started the works. And we also imposed a launching method. It has a better execution quality. Remember what I told at the start of my speech? I was talking about simplicity of construction, security for the workers, repetitivity, and quickness of the construction. it's been offset by the launching method. And also we avoid traffic conflicts with the speedway running under the bridge. So this is a view of the start of the launching. You see all these piers that have been cast before the bridge comes over it. So the principle was this one. You had this steel nose that was used to help reaching the next pile every time. You had the first concrete elements, and the crane added the casting material. A new section of 12 meters was cast on side, and the whole structure was pushed upon the existing piers. This is a view of the construction. You see that the speedway keeps in service, and there is nobody walking in there. It's only it's only a forest of columns, but everybody walks at the backside. So this was another video, but I guess I might have the same problem as the previous one. It seems to work. So let's have a look at the construction. This is the casting area. This is the steel nose. This is the first element, and when it's dry, it goes on, and we push the whole structure. At the end of the launching, it became a world record for the weight of the concrete structure to be launched, 65,000 tons. It speeds up a little bit, but you see how it has been done. The connection to the canal, then it's been filled in by water, and the first boats came through it. And we added some important surroundings, green surroundings. Here is a series of pictures of the realized work just after. This is one of the first boats crossing the bridge. And this is a series of pictures after the green improvements. These were closely connected to water, because these water areas are inside the bed of this small river I was talking about, and they have become recreation and also environmental areas that are really appreciated. We have also created some biking path. To end up with this kind of structure. You see that the green horizons haven't been broken by the structure. Of course there are roads, but there were already roads before, and we try to, again, not to push, but to lay the bridge on its surroundings, such as we had touched nothing. But in fact, under those piers are very heavy foundations with large boreholes and all the technique that I've been just explaining. This is another view. You see that the village keeps connected to the surroundings, the river, and these green areas without having a wall in front of it. So I will now come to my conclusion and just repeat the main facts. We face an expansion of inland navigation, which we're proud of, but it needs typical answers in the hinterland. We need larger inland ports, bigger locks, larger waterways. And with all of these aspects, we have to rearrange our historical city harbors. And I'm glad that this topic was also given by previous lecturers, as it concerns a lot of cities. So two distinct challenges. This is an example of a weir that we've just ended up. It's on a river called the Dander. It's in Belgium, and it's an automatic weir. So nobody works in there, but we need it to have a fully automatic structure with with an equipment building. I think that we must think about simple solutions, about logical solutions. And so I would say that my wish is to promote strong, simple, undecorated and plain solutions, a respectful approach of the landscapes, and durability of the structures and the spaces might be found through such a peaceful approach. And thank you for your attention.
I would like to thank very much to David for this very interesting presentation. I would like to invite him to come here to sit. And so we have a little time now for some questions from the audience, if you want to have some questions. And please, por favor, poderia acender as luzes? Olá? Bem. Obrigado. Well, I should thank very much David, because he has given very interesting examples of how we can mingle hard engineering with landscape, with the soft aspects of landscape. I think that was one of the richest conclusions that we gave to us, how we can put together this challenging to bring this huge hard work of engineering, at the same time mingle this with the existing landscape and give an upgrade to this landscape. So I think this was one of the most interesting challenging that we are fronting now. How we can put this infrastructure and landscape as part of the same effort to give more sustainable use for water, for other areas, for channels, for everything that's connect us to our cities and our environment. I think now you can have some questions if you would like to address.
Interesse em alguma pergunta, por favor? Comentários? Comentário, por favor. Não, claro, eu não sei se você precisa da passada. Pega o microfone, por favor.
Boa tarde. Meu nome é Carolina, sou estudante de arquitetura e nós estamos engateando ainda nessa área. E chegamos aqui nesse simpósio cheio de dúvidas e expectativas. E sobre esse trabalho, primeiramente, eu gostaria de parabenizá-lo por esse trabalho brilhante que tanto nos inspira. E a nossa pergunta dos meus colegas é como fica a questão desviando a água dos rios, como que fica a questão do equilíbrio ambiental da fauna e a flora se afeta a vida dos peixes, como que vocês lidam com essa questão?
Thank you for this question. I think it's a very important matter. In fact, I haven't had time enough to talk about this today. I will give two different ways of answering this. First will be the example of the lock of Liège. The lock is situated on a channel, and of course the channel has no debit. It takes all its water from the river, and at dry periods, the accumulated consumption of the locks is similar, not equivalent, but in the same, let's say, in the same order of the one of the river. So it was the answer about water consumption was given by this pumping station to balance this during dry periods. Otherwise, the Meuse, which is which has about no navigation, would have had a lack of water, and so the banks would have been poorish. There are a series of fishes, of birds that live along the side of the river, and the variation of the level of the river during those dry periods would have been a real shame. So the first thing was absolutely to create a balance during all periods. So that's the first kind of answer I can give. The second one is also related to this example. By building this new lock, we had to take over some spaces of some surfaces that were previously dedicated to environmental zone. This was a great, of course, a great discussion with many people because we were affecting, we were injuring a zone that was really important for environmental aspect. But on the other hand, we were promoting the inland navigation, which we all know is one of the most sustainable ways to transport goods. So by doing this, we made a local injury for a global improvement. So we just tried to deal with it. It was necessary for the general purpose, but on the local aspect, and we talked about this morning as well, on the local aspect, we tried to find a solution. And this solution was to reappropriate the zone and to help all the fauna to keep developing there, and to add, as you saw on one of the pictures, and to add an extra zone to balance the loss of the surfaces that were dedicated to these important fishing areas. And this is something I would say quite new in Northern Europa, to have such a, you know, the budget that has been dedicated to environmental aspects in the case of the block of Lannet, sorry, is more than 15% of the global budget. So this is important when you see the amounts that we speak about. So it's a real conscience that has been grown inside all the stakeholders and the people that are involved in these investments. This is something important. And the other point, more general, that I wanted to say to answer your question is how could I say, the path of the fishes from the sea up to the place they will, I don't know the word in English, but they have to make the reproduction. So this is very important that we offer the fish, all kinds of fish, because they don't travel, let's say, or they don't move the same way. So some kinds can jump little steps of 30 or 40 centimeters. Some others need a continuous slope. Some others need some rigidity on the slope to help, like some kind of fishes that have to snake along this. So for all these types of fishes, it's important that they get the opportunity to reach their final destination. And there has been a European decision that imposes at, I think, a very short term, now it's, because it's already been decided a few years ago, I think it's over 5 years, that you must, every region that is crossed by a river has to guarantee a certain percentage of survival for all these fishes that are crawling along the river. And so it has asked the owners of all the equipment to add specific fish passages. That is for the weirs, for the hydroelectric station. So every time we make modification in the way of the river, we automatically organize a fish passage. And in the case I showed you earlier, these 2 locks of enceintes that are doubled, we made a new kind of artificial river on the left bank. So it's not a stairway, it's not a step, but it's a real inclined plan where the fish can climb up. So this is the way we handle the
think that I can call what you're doing as good examples of green infrastructure. No? Because you're dealing with infrastructure that also give environmental services, ecosystem services. Very interesting. Any more questions, Schumann? Please. She's first there. Primeiro, ela chamou a primeira, por favor, Nina.
Boa tarde a todos. Quando o senhor fala decisão europeia, uma vez que se trata de vários países, e mais do que isso, de vários municípios, até não sei se eu estou falando certo, mas o que significa essa decisão europeia? Tem um congresso, tem um comitê, o parlamento, como se cria essa política europeia que envolve uma série de países?
Thank you. This is quite a political question, but in Europe there are a series of matters that have been transferred to Europe. That means that as a citizen there is a certain part of the laws and the decisions that are still decided inside each country, and what other fields concerns, the decisions come to the Europe. So every country has to take this decision and translate them into their own legal system. So it's not a direct imposition because each country has its own laws, but they have European directives that must be transferred to each state member. And this was the case. There is about environmental aspects and fishing. There is a European group that was led by the European Commission that gave a series of objectives. You must know that most of the time these are not completely compulsory. Those are recommendations, those are objectives, and member states have a certain time, in this case I think it was about 10 years, to be aligned with this decision. And this gives them the time to translate the European recommendation into a national rule and to make it execute. If it's not completely achieved at the end of the period, well, you're not going to jail. I mean, it's a goal, it's an aim that every state has to reach. If it doesn't reach, it might get some problems with the Europa, some financing of certain projects that might be slowed down. So you have a series of answers that can come from Europe to promote and to invite the member states to answer the requirements. And in this case, it was decided so.
Obrigado. Nós temos mais uma questão aqui que foi levantada. Depois nós estamos com questão de tempo, então nós tínhamos inscritos uma questão. Alguém tinha perguntado mais ou menos? Não, né? Você? Então, outro, e acho que podemos considerar essa parte.
Em primeiro lugar, Eduardo, parabéns pela apresentação desse complexo. Melhores tecnologias vão avançando em relação a que os elementos da natureza se adaptem aos interesses do homem e consigam uma bissetriz de uma boa condução dos problemas que são apresentados para nós todos nas cidades do interior, no alcance aos portos, etc. Eu cheguei um pouco atrasado. Eu não sei se o David já falou sobre alguns dados bem concretos, objetivos que eu pergunto. Primeiro, quando é que começaram os primeiros estudos desse complexo? Segundo, quando começaram as obras? Terceiro, qual é a distância desse complexo até o mar? Quarto, qual é a oscilação do nível da cota da água entre o nível normal de curso do rio até a previsão daquela água na parte alta do canal? E quarto, se essa altura for muito alta, como é que fica a comunidade desse lado, de um lado, numa margem do rio, sem poder enxergar a outra margem do rio? São algumas dessas questões que eu coloco que, de uma forma bem clara, objetiva, bem simples, porque são perguntas meio básicas. Obrigado.
Thank you, Rick. So, to answer your questions, the studies, I'm talking about the fourth block of planet. The studies started in 2004, and the complex ended up in 2015. So, it took 11 years to make the studies, get all the authorizations, ask for the prices, and get the structure built. Second, you were talking about the duration of the work, I think. It took the work itself, the work themselves took 4 years and a half. Then about the height, the canal, so the different 14 meters, so the canal upstream is at level 60 above water level, and downstream is 46 above water level. So to reach this point from the port of Antwerp, there are 6 locks that lead the boats from level 0 till level 60. So that's the path of the Canal Albert up to this site. And about the impact on the citizens, I think I will need, well, I don't know, we're running out of time maybe, but I'll be very quick. Maybe we'll have a short conversation afterwards. But I would just like to say that the canal is located against the side of the valley. So it's an artificial canal that has been built that is higher than the river itself, and it's really against the side of the valley, so that it doesn't really change the perspective that people can have. Without the canal, they would have had maybe 100 meters further, they would have had the side of the valley anyway. So it's a kind, the question of the point of view was not really a big issue in this case. On the contrary, for the project of the Pont Canal, it has been a great question, because the structure is 6 meters thick, and it's up in the sky. So for the citizens, for the village that is just close to this, it is a structure that has a certain presence. That is true. But again, you must see it in this context, that at each extremity of the bridge there are big earth fillings that already existed for the construction of the canal. So thanks to the limited number of piers, and thanks to the fact that the structure is loading itself, so it doesn't need any beam underneath, it keeps the thinnest possible, so that underneath views get possible, keep possible. So it was again the best compromise you could find to promote the waterways.
Okay, thank you. So another question here. Por favor, uma outra questão rápida aqui.
Essa ponte canal faz parte do complexo do elevador de Strepitier?
Yeah, it leads to the elevator you showed yesterday.
Mais uma última questão, por favor, uma pergunta. Daí podemos dar como encerrador, Roberto.
Posso fazer em português. Primeiro, parabéns pelo trabalho que você apresentou. Nós tivemos a oportunidade, junto com o professor Wagner, de estar presente em ver pessoalmente os trabalhos que você realizou, mas eu tenho duas perguntas que eu acho que uma é ligada um pouquinho à engenharia ambiental e a outra um pouquinho mais técnica, porque eu sou engenheiro, acho que é o único engenheiro naval aqui presente. A parte técnica é em relação aos canais. Normalmente, os canais que são construídos, e é um hábito bastante grande na Europa, existirem canais para permitir a navegação, eles estão situados num nível superior em relação ao leito dos rios. Existe perda de águas por esses canais são feitos diretamente sobre o solo, ou existe um tratamento do solo para que exista uma perda mínima de água, ou não existe perda considerada nesses canais. Essa é uma pergunta técnica que sobrevive dependendo do solo que vocês têm na região da Europa. A segunda coisa é que torna-se um hábito ver na Europa canais para melhorar a navegabilidade, e é uma coisa importante haver a navegação, porque a navegação é um meio de transporte mais barato que existe. E os países que fizeram canais, eles com certeza são os países que melhor resolveram o problema em relação às crises mundiais. São os países do norte da Europa. Vocês, a gente pode perceber que vocês estão indo bem, enquanto que outros países do sul da Europa não estão tão bem quanto vocês. Então, a construção de canais é um fato. Sendo assim, você poderia quantificar quantos canais, qual é o percentual de canais que existe, por exemplo, no norte da Europa ou na Bélgica, em particular? Qual é o percentual em relação aos rios navegáveis e os canais construídos artificialmente? Se isso for possível dizer. Uma outra pergunta, que é uma pergunta mais técnica. Tenho percebido pelos seus desenhos que as áreas aéreas construtivas, como pontos, vocês têm usado muito materiais alternativos, que hoje em dia já não são tão alternativos. São materiais tipo metálicos. As partes mais próximas ao solo, eles continuam usando bastante concreto. É uma tendência, na geral europeia, há um problema econômico ali que justifica esse tipo de construções?
Thank you. I will answer in the order. So the first question was about the way we ensure the waterproofness of the canal. In fact, it's not fully waterproof, but we add a clay layer underneath the canal of about 50 centimeters, which is compacted at the end of the construction before pouring water, and it gives quite a good result. So the losses of water are really reasonable compared to the consumption of the locks and the evaporation. So it's really neglectable. We also have a series of, maybe we can talk a bit later with this, but we have a series of protection under the quay walls to avoid that this water, this leaking water, could slide or could flow underneath the quays and damage their stability. There are also protection systems, but for the waterproofness, it's mainly this clay layer that is used. Then you were talking about the number of, the amount of canals that are built. I don't have the right numbers, but I know that in Belgium it's about 40% of the navigation, the navigation lines that are realized thanks to canals. Canals or rivers that have been heavily canalized. I don't know the ratio for the whole Northern Europe, but for sure in the Netherlands it's probably even more.
I'd like to thank you very much, because we ran out of time now. So sorry, I think you can discuss this later in the break. Thank you again, David. It was a very interesting presentation, and I hope you enjoyed that time.
Senhoras e senhores, finalizando essa primeira parte do período da tarde, a doutora Saile gostaria de fazer alguns avisos, peço por gentileza que estarem só mais um minuto para que ela possa fazer esses avisos. Muito obrigado.
E agradecer ao Wagner Ferreira, que está aqui cumprimentando o David, né, por esse intercâmbio com a engenharia portuária, e agradecer a presença do professor Paulo Pellegrino também na mediação, e fazer para vocês alguns avisos, né. Então, nós estabelecemos um contato com a engenharia naval, através do nosso pesquisador, Eloy, que está aí, né, e temos amanhã um horário de visitas monitoradas para os interessados ao laboratório, para visitar a área de simulação de navegação, né, o simulador. Então, os que estiverem interessados nesse assunto, procurem ali a listinha com o Daniel e a equipe na frente, na recepção, marquem os nomes, que é amanhã de manhã, tá? Então, esse é um aviso. A outra questão também do nosso seminário, nós fizemos com a Sabesp um convênio, eles estão aqui saindo da rampa à esquerda, na ruazinha, com uma exposição itinerante, didática, para toda a população aqui da cidade universitária, vocês devem visitá-la, tá? É um acesso franqueado, gratuito, e é muito interessante a respeito de processos de tratamento de água, está aqui até hoje, no final da tarde. Temos também a questão da exposição, a nossa exposição internacional de projetos que está lá no subsolo, com vários trabalhos de professores, estudantes, profissionais, escritórios, sobre o assunto, fazendo uma conexão com o tema do nosso seminário. E também o júri o comitê científico, ao longo do tempo, vai fazer uma análise. No dia 8 de dezembro, teremos um resultado para algumas menções e referências que estarão todos os trabalhos disponibilizados no nosso site. Também agradeço aos palestrantes e conferencistas que estão disponibilizando seus artigos científicos e que nós vamos colocá-los também no sítio oficial do nosso evento. Queria também avisá-los que agora, durante o coffee break, nós vamos ter algumas assinaturas de alguns livros que estão na livraria, né? O arquiteto Rui Otaki, muito bem-vindo para a próxima apresentação, também irá assinar um dos livros que está lá. A professora Marlena Lur participa também como organizadora, né, do livro Em Busca da Sustentabilidade, que também está ali na livraria, e tem um outro que é Paisagem e Infraestrutura, uma pequena coletânea, que também está lá na livraria. Então, teremos esse momento para assinatura, os autógrafos dos autores, e não sei se esqueci mais alguma coisa. Temos também aqui a presença da nossa presidente da Associação Brasileira de Arquitetos Paisagistas, que eu queria registrar, né? Muito bem-vinda para fazer a assinatura da Carta da Água, que vai acontecer, né, no período agora em seguida. Então, eu peço a vocês que continuem assistindo e que os interessados realmente procurem lá para a gente fazer a lista de quem irá fazer a visita no Laboratório de Engenharia Naval aqui da Universidade de São Paulo. Então, muito obrigada, desculpe, mas eram muitas coisas que eu tinha que falar para vocês, tá? Obrigada pela atenção.
Enquanto as senhoras e os senhores vão se localizando para o café, nós gostaríamos de lembrar a todos que este evento só é possível graças aos nossos apoiadores e gostaríamos muito de enfatizar que a promoção e organização com a cargo da NUTAU SP, da ideia, da parceria com o Conselho de Arquitetura e Urbanismo de São Paulo, o apoio à pesquisa da Angel, Atlas, Carmen e Cultura. Seria interessante que todos aqui presentes pudessem olhar o painel para verificar quantas organizações estão nos apoiando. Muito obrigado.